The next one's back to simplifying square roots. So when we did our square roots, you wrote down the list of perfect squares, hopefully, somewhere handy. Because we're going to do the exact same thing we did before, only now we're going to add or subtract when we're done. With algebra or anything else, when you add and subtract, you have to have like terms. So if I have a square root of 5 plus a square root of 3, I can't add them because they're not like terms. I would have to have something like 5 square root of 5 plus 2 square root of 5, where they both have the exact same end part. So I'm going to simplify these just like I did before. If I have the square root of 75 to start with, I want to factor that. The biggest perfect square that divides into 75 is what number that's a perfect square divides evenly into 75?
I would say 5.
Okay, but 5's not a perfect
25,
square.
I mean.
25. That's what I'd say, 25, exactly. So 75 is 25 times 3, right? Then we can do the square root of 25, which is 5, and I get 5 square root of 3. That one's simplified as much as we can simplify it. So now I'm going to do the minus 3 square root of 27. The minus 3 stays out in front, and I'm going to simplify the square root of 27. 27, what perfect square divides into 27?
9.
9. 9 times 3 is 27. The square root of 9 is 3. That's going to come out in front, and it's going to be multiplied by whatever is out there already. So now I have 3 times negative 3, which is negative 9.
Uh-oh.
And the board decided to go crazy on me. Negative 9 square root of 3 is what we had there, right? What was our other one? Our other one was 5 square root of 3, wasn't it? You have all the rest of the work up to there. So we have 5 square root of 3 minus 9 square root of 3, right? 5 minus 9, we think about like we would a 5x minus a 9x. We're just going to subtract those front numbers. 5 minus 9 is
4.
negative 4 square root of 3 then. Going to be our answer. So number 5 there, we have 2 square root of 45. I'm going to leave the 2 for now. I'm going to factor the square root of 45. Biggest perfect square that divides into 45.
Nine.
9, exactly. 9 times 5 is 45. The square root of 9 is 3. That's going to go out in front. We're going to multiply it by that 2 that's already out there. So 3 times 2 would give me 6 square root of 5 when I simplify that first term. Now I've got that plus square root of 20. 20 is not a perfect square. We can factor 20 into
4.
4 times 5, exactly. 4 is my perfect square. The square root of 4 is 2. So I get plus 2 square root of 5. And if I take 6 square root of 5 plus 2 square root of 5, I'm going to get
What'd you say? I was doing that.
the 6 square root of 5 plus the 2 square root of 5.
You add them?
You add them together, you add the front numbers together, you get 8 square root of 5 then. So you think about it just the same way if I have 6x plus 2x. We get 8 x's, right? So the front numbers we add together, this is my label so that I have like terms. It's how many of those square root of 5s I have. So number 6, same kind of thing. This time I have negative 4 square root of 18. Oops, I better write the 4 in there. Negative 4 square root of 18. The 18, of course, isn't a perfect square again. We want to factor 18 into
2. Oh no.
18 is
9.
9 times 2. So 9 times 2. We then take out the square root of 9, which is 3. We multiply it by what's in front, so now I'm going to get
Negative 12.
negative 12 square root of 2, right? Then I have that minus square root of 8. 8 is not a perfect square, but I can factor it. 4 times 2. The square root of 4 is 2, and so I'm going to have minus 2 square root of 2. Right, that minus sign is like a negative 1. Negative 1 times 2 is negative 2. So now I have negative 2 square root of 2 minus 2 square root of 2. They are like terms. Going to go ahead and combine those, and I would get
What, 14?
negative 14 square root of 2. Add and keep that sign, right?